Hello everybody and welcome back to another video by FunLearn Tutorials. In today's video we will be carrying forward with the Jones 1965 model and I shall be explaining how we got this equation. So it was sort of left as a homework. So how do we get the equation? PM equal to ALMW plus AKMR. Let us recall just a quick recap. Essentially, when I consider the manufacturing sector, there are two inputs that go into the manufacturing sector. One is the labor input and the other is the capital input. Now we define that ALM is the amount of labor that is used to produce 1 unit of manufacturing sector, 1 unit of output of the manufacturing sector. So if I have to produce one unit of manufacturing output, I'll have to spend or I'll have to employ ALM units of labor. Similarly, if I have to produce 1 unit of manufacturing sector output, then I have to employ AKM units of capital. Again, that is as defined, AKM is the amount of capital that is used to produce one output of the manufacturing sector. Now, we assume that W is the wage that is paid to every labor. So, if I pay W unit of wage, W wage to every unit of labor, then I have to pay ALMW. Essentially, let me just write it here. WALM will be the total wage bill that I have to pay to all the labors that I am using to produce 1 unit of manufacturing output. Similarly, if I assume that R is the return on capital, basically the capital cost that I have to pay or incur to every unit of capital that I employ in my production process, then total of AKM capital have been used in producing 1 unit of manufacturing product. So I have to incur R into AKM, that is the total. So this is for this is the number of capital unit, this is the cost of each capital. So they together form the total capital cost that I have to incur. So this is the total labor cost. If I just remove these two, this is my total labor cost to produce 1 unit of these are both for 1 unit of manufacturing good. So this is my labor cost and this is my capital cost. R into AKM is the capital cost. So if I add these two, this is the total cost. This gives me the total cost. As you can realize, that is actually the right hand side of this equation 2. That is W into ALM plus R into AKM. It's reversed order, it doesn't matter. That is the total cost. Now, if I consider the revenue part, if I sell 1 unit of manufacturing product in the world or in the domestic market, essentially I assume that PM is the price of 1 unit of manufacturing product. So that will be the revenue. This is the revenue from 1 unit, from selling essentially 1 unit of manufacturing good in the market. And as I have explained in the previous video, this is exogenously given because of the assumptions essentially that it's a perfectly competitive market. So price is given. Besides, it's a small open economy. So the economy itself has no control on the market determined price, which is determined in the world market here because it's a topic of international trade, as you can realize. So essentially this revenue has to be equated to the total cost of producing 1 unit of manufacturing output. So PM has to be equal to this. So that gives me the two equations. I have this from the agricultural production side, PA equal to ALAW plus AKAR, and I have PM equal to ALMW plus AKMR. That this equation 1 is from producing the agricultural unit, agricultural output, and equation 2 is from producing the manufacturing output. These two constitute the equations from the producer side, as I had started here. So these were the producer side. Now let us go to the consumer side. So if I go to the consumer side, essentially I will be dealing with the full employment assumption. So now I am considering the consumer side. So let me just write that down. In short, this is the consumer side. Now, as you can recall, the total amount of labor that was essentially sent to the I keep removing these sectors. So the total amount of labor that was sent to the agricultural unit was ALAXA. Remember, so as I had mentioned, ALA is the amount of labor required to produce 1 unit of agricultural output. Then I said 1 unit of agricultural product requires ALA units of labor. So if I assume that I will be in total producing XA amount of agricultural output, then I will need ALA into XA amount of agricultural output. So ALA XA is the total labor that is sent into the agricultural sector. So essentially I write ALA into XA, that is the labor that is sent into the agricultural product. Now going by the same logic, if I consider the manufacturing sector, because labor is sent to both agricultural sector and manufacturing sector, right? If I go up, then I can find out that labor is sent to both the agricultural sector and manufacturing sector. Now going by the same logic again, ALM was the amount of labor required to produce 1 unit of manufacturing sector. And if I assume that the manufacturing sector produces a total of XM units of output, then for 1 unit of manufacturing sector, ALM labor is required. So for XM amount of manufacturing sector, XM into ALM amount of labor will be employed. That means the labor that is going in this direction is actually XM into ALM or ALM XM, whatever, the direction doesn't matter. So XM into ALM. That means another part of the labor is actually ALM XM. So you can see that L bar has 2 sectors or 2 components here. Let me say L bar has 2 components. One is ALA XA and the other is ALM XM. Recall that we had considered the full employment condition. That means this and this constitute the entire labor force. There is no other part which is left unemployed. There is no surplus labor. That means we can write from this concept, we can write ALA XA plus ALM XM, that were the 2 arrows that were leaving out of the box, that has to be equal to L bar. So that is the third equation that we have. The first equation was the production side of the agricultural sector. The second condition was the production side of the manufacturing sector. The third sector essentially is the balancing condition for the labor factor, labor market basically. Now we consider the capital market. So to consider the capital market, again, as you can guess, we will have K bar on this side because the capital has to be distributed within the agricultural sector and the manufacturing sector. So here, assuming that AKA is the amount of capital that is required to produce 1 unit of labor, and again I am assuming XA amount of output is produced to maintain consistency, of course, then some amount of capital that is sent to the agricultural sector will be AKA into XA, because for every unit of agricultural output, AKA labor is required, and we have a total of XA units of agricultural output being produced. So the total labor that is the total capital that is sent into the agricultural sector is AKA XA. Similarly, we need AKM units of capital to make 1 unit of manufacturing sector output, and we are producing a total of XM units. So this is the labor required for 1 unit. These are the total number of units being produced. So this is the total amount of capital sent to the manufacturing sector. So when we add these two, then we get the total capital endowment. Again, recalling from the fact that we have full employment condition, these two have to add up to K. This gives me the balancing condition for the capital market. So we have 4 conditions here essentially. We have 1 condition from the production side of agricultural sector, we have 1 condition from the production side of the manufacturing sector, we have 1 condition that balances the labor market, and we have another capital that and we have another equation that balances the capital market. Essentially these 4 equations conclude the equational structure of the model. So you can understand that if you know how the model works, you do not need to remember the equations, they can be derived from the concepts. And if essentially what I usually do is I draw a diagram like these. What are the sectors that are required, what are the factors, and which factor moves into which sector. That gives you a brief idea, and if you remember this notation of Aij, essentially if you remember this notation and if you assume the outputs and prices properly, then you can derive the equations on your own. That essentially concludes the equational structure of the model.